Hey y'all, Data Guy here. And today I wanted to make a video really just covering all the different types of data architectural options you have to handle big data these days. As anyone that works in data knows, your data architecture forms the backbone of your IT infrastructure because everything needs data, everything produces data. So choosing the right data infrastructure is really crucial for optimizing your data management, scalability, and then just powering future data analysis and powering your business. So while I've given you I've given you some videos on best practices, this is really going to be breaking down the different types of high-level architectural options with an eye towards, hey, these are the use cases that this particular architectural option is good for. Here are some of the pros, here are some of the cons that you might have to deal with when implementing this, so that you have a really clear idea of what the right approach is for you, and you can implement it, and you know, hey, these are the pitfalls I should look out for, these are the benefits I should be gaining by implementing this. So without further ado, let's get into it. So the first data architecture option is one you are probably familiar with, and that is just a regular data warehouse. And in a data warehouse style architecture, you're just going to have one centralized repository that is going to ingest all of your data from all of your different applications, logs, files, metrics, and then once the data is in there, either after it's been transformed or by transforming it within the context of the data warehouse, you then can facilitate complex queries and analysis because you clean the data, you massage it, you bring it into a really specific format. So it makes it really easy for you to then pipe that data out to your various data marts, which represent kind of the different teams that consume the data. So from this larger aggregate data warehouse, you can send the sales team their respective data, the finance team their respective data, marketing team their respective data, and it's in a clean format that they can immediately begin consuming from and generating insights from. So some typical use cases you'll see a standard data warehouse architecture supporting are historical data analysis, business intelligence, reporting, and then just general data consolidation from multiple sources. Because in its pros column, it's got really high performance for complex queries. Once you've cleaned that data, it's easy to perform those queries because your data is optimized for it. And then you also have structured, organized, clean, ready to use data that can be optimized for read-heavy operations because you have all these different teams reading from a single database. So you can kind of get the economies of scale there by optimizing for those read-heavy operations. Cons are there is, as you can imagine, stuffing everything into a single database can get expensive. There's a pretty high initial setup and maintenance cost unless you have a dynamically scaling database option. And there's also schema changes are pretty inflexible with data warehouses. Once you've kind of developed, your gold standard schema and your gold standard data model, it's really hard to change that in a serious way. Obviously, you can bolt some things on, but even that, like, you got to think about second order impacts. And it is really limited to structured data, typical like CSV, columnar format data. So more exotic data formats like videos, like audio aren't going to be able to be stored here. Second architectural option is a data lake architecture. So in a data lake architecture, you really just have a pretty semi-unstructured storage repository that just holds tons and tons of raw data that you ingest from any sources. Could be documents, could be chat logs, could be device logs, IoT sensor. You can see some examples here. They even get more exotic. Could be videos, could be consuming YouTube content. Any kind of structured, semi-structured, unstructured data, just toss it all in the data lake, and then it's designed to essentially, whenever you actually need to use the data, at that point in time, performing some cleansing processes, ETL processes on that actual raw data to then use it for downstream analytics, machine learning applications. So it's really designed for supporting big data analytics where it's conceivable, but it's not efficient to really process all that data as it's generated. You really only want to use and process a subset of that data at any one point in time. So designed for machine learning, data science type workflows where you just need a ton of different types of data that you want to collect from as many sources in as raw form as possible. And the pros of this approach is that you can handle really large volumes of data really easily. You can just slap on additional unstructured storage. It's got a very flexible schema on read approach where you just automatically infer whatever structure the data is being read in with. And it supports a ton of diverse data types, as I already mentioned. The cons with all these benefits is that this can rapidly become what is known as a data swamp without proper governance, where you just have a ton of data and no idea how to use it. And you also are typically going to run into slower query performance compared to data warehouses. Number one, because you're querying unstructured data, and then Number two, because you have to then process all that data before you actually use it. And there's typically just more data as well. And then finally, it really does require some advanced data management skills to ensure you have the proper guardrails in place to make sure that this doesn't become a data swamp. Everything is properly organized, but done in such a way that can support a really wide variety of data really easily. Now, the next option I got for you is a data lakehouse. And you can actually see an example of this with the Visio lakehouse I have here up here on the screen, where you can see this really combines the best of both worlds. You have a data lakehouse approach, but with data warehousing attached. So essentially here you have the benefits of both traditional data warehouses and data lakes in a unified environment for both structured and unstructured data with advanced analytics capabilities. So here you still have the kind of option to ingest all this, not the option, but you ingest all this raw data, but then within the confines of this data warehouse, you then have different processes that are automatically consuming this data, automating the ingestion of it, filtering, cleaning, augmenting them, bringing some of that clean data into that data warehouse while still providing access to the larger amounts of unstructured data. So your data analytics team can get those really quick, real-time data analytics on structured data, but also have an option to go delve into that realm of unstructured data and then use those same processing rails to process that data for whatever particular needs they might have. And this is really great for hybrid analytics, where you need some analytics that's real time, some that might be more focused on things like ML models, where unprocessed data is really crucial. And then also just unifying your data management instead of kind of forcing all your data into a data lake approach or a data warehouse approach. You get kind of the benefits of both here, and it's just an integrated environment for all data types. And then finally, on kind of the pros column, is it's really scalable and flexible. You're kind of bringing a lot of different components together, but even though it's a lot to manage, you do get all the benefits of all those respective components. However, on the cons, you have the complex implementation and management of such an approach, which often comes with higher costs as well and requires expertise in both data warehousing and data lake technologies. So even though you're not going one or the other, you need to know how to effectively make the best use of both in order to get the best out and the most out of this data lakehouse approach. So the next concept or data architecture option I want to talk about is the modern data stack, or what I really think of as just a cloud native approach. And this is an approach where you kind of break yourself free of the confines, thinking about, hey, I need to have one big data warehouse or one big data lake, and really just focus on creating a web of cloud-based tools and technologies for particular use cases, and just getting whatever technology you need without thinking about, hey, and I mean, obviously you can have an overall plan, but without trying to conform to, hey, this needs to be a data lake, this needs to be a lake house. And you can kind of see an example of this where you have, you think of your data more in that pipeline approach. Hey, what is the end use cases we're trying to power, and buying and implementing tools that power those use cases. So in this case, you really think about, hey, things like data integration, things like transformation, visualization tools, taking a more holistic approach and really focusing on kind of, hey, yes, our data is stored in Snowflake or Redshift or Databricks, but what are we doing with that data afterwards? And really facilitating, this is the best use case for cloud native data management, where you don't want to have everything on-prem. You want to be agile and scalable, because the beauty of these cloud solutions, you can spin them up and down really, really quickly. You're not handling any underlying infrastructure, and so you can really enhance and speed up your deployment and iteration cycles by implementing just a tool set from the base as cloud native. And then so pros on that are scalability, flexibility, much lower upfront costs with pay-as-you-go models, and then integrations with your various data sources, tools. So you really can just plug and play any systems that you think are interesting all into your cloud architecture. And so hey, I want to start doing some reverse ETL. I want to start piping in customer information. Buy Census, buy one of those tools that will pipe that in, right? And then integrate that into the rest of your cloud architecture. Cons in this approach are really just a dependency on cloud providers. So you have a potential for tool sprawl, integration challenges, and then you need to have a solid plan and a plan for also monitoring and optimization, things like Airflow to manage all these different systems in conjunction with each other, so you don't just have sprawl where you're not really using a lot of systems you've actually bought. So, the modular approach has its pros and has its benefits and drawbacks because, hey, you might actually, you really need to know what you're buying and have a plan to use it rather than just, willy-nilly adding pieces of software. So the next model I got for you, or model of architecture, is the Lambda architecture. And so the Lambda architecture is a data deployment model for processing that consists of a traditional batch data pipeline and a fast streaming data pipeline for handling real-time data. So in addition to the batch layer and speed layers, you also have an architecture that includes a data serving layer for responding to user queries and then also serving that data back to the underlying batch processing serving engines. So really focused on enabling robust and fault-tolerant data processing, combining streaming and batch processing to get data as fast as possible. And this is really good for systems that require really truly real-time analytics, systems that require high availability, fault tolerance, and then also applications that require both batch and streaming data processing, which is almost every application out there. And some of the pros of this approach are that it handles large-scale data processing really well by combining both batch and streaming, and it's also fault-tolerant, highly available. So just a really robust system for handling data. However, with this robustness comes complexity in managing the multiple layers, and then also having data consistency challenges between the batch and speed layers. So there's a higher development and maintenance effort to actually make this architecture work in the way it's designed to. Now, similar to the Lambda architecture, but with a couple small key differences, you have the Kappa architecture. And so this is where you have a software architecture for processing streaming data that can perform, again, both real-time and batch processing, primarily for analytics, typically within a single tech stack, like using something like Apache Spark. And this eliminates the batch layer. So you actually focus on stream processing most of the time, and then, or in motion, but then you also, and so I guess saying it doesn't focus on the batch layer is a little bit of a misnomer, but the batch app is just processing data at rest after it's already been processed by the stream layer. So you can use batch processing for, if you want to then change that data or use it for another downstream process, but this really focuses on just using real-time processing for your day-to-day kind of ingestion of data. So this is good for situations where you just really want to focus on real-time data processing, but have the option to do batch processing for more bespoke or more irregular data changes. And so well suited for scenarios where batch processing isn't necessary and applications that require that continuous data flow on the order of millisecond lag time in terms of your most recent data coming in. Pros of this are a simplified architecture with efficient real-time processing, and also this is really just designed to have super low latency. However, on the con side of things, it's much less suitable for historical data analysis and requires robust stream processing infrastructure. And then also there's potential challenges with data reprocessing if you aren't careful about, hey, what batch processes am I actually executing here? And so those were really the 5 data architecture options I wanted to share with you today. Just was kind of reading about these and thought it would be interesting. So hope you enjoyed this video. Hope you have a great rest of your day. Data Guy out.